Hello everyone, welcome back to my channel. Overall good at educating. So today let us learn a new lesson, that is electricity, from the class 10th. This chapter we have important problems, we have a definitions, then diagrams. These are all very important in this lesson. So let us learn each concepts in detail. The first concept is charge. What is a charge? A charge is a fundamental particles in an atom. It may be positive or negative. So what is a charge? A charge is a fundamental particles of an atom. Any atom is made up of what? It is consisting of a charge. The charges may be positive charge or a negative charge. Okay. We have some two important points to remember about the charges are like charges repel each other. Unlike charges attract each other. Like plus and plus will repel each other, whereas plus and minus will attract each other. Okay. So the SI unit of the charge is coulomb. Its symbol is capital C. Okay. What is 1 coulomb? 1 coulomb of charge is equals to charge present on approximate 6 into 10 to the power of 18 electrons. Okay. So charge of 1 electron is equals to negative charge of 1.6 into 10 to the power of minus 19 coulomb. That is, with the formula we can tell Q is equals to Ne, where Q is equals to charge, N is equals to number of electrons, and E is equals to charge on one electron. So the formula to find the charge of an electron is Q is equals to Ne. Already you know that Q is nothing but a charge and N is a number of electrons and E is the charge on one electron. Next is current. Current symbol is I. Current is nothing but the rate of flow of charge is called current. What is a current? The current is nothing but the rate of flow of charge. Okay. So what is the current formula? See, current is equals to charge by time. So you already know current symbol is I, whereas charge symbol is Q and the T time symbol is T. So formula is I is equals to Q by T. SI unit of a current is ampere. What is the SI unit of the current? SI unit of the current is ampere. We write it in the capital letter as A. So 1 ampere is equals to 1 CS minus 1. That is 1 MA is equals to 10 to the power of minus 3 A. That is 1 mu A is equals to 10 to the power of minus 6 A. That is current is measured by ammeter. How the current is measured? Current is measured through the ammeter, where the SI unit is the ampere. So you can see the symbol on the screen how to write the ammeter symbol. Okay. Hope you guys have understood what is a current. A current is nothing but the rate of flow of charges, that how many charges will flow. Based on the charge we call it as a current. Okay. And current symbol formula is charge by time. I is equals to Q by T. The next we have ammeter. Ammeter has low resistance and always connected in series. How it is connected? Ammeter is always connected in the series. It is not connected in the parallel. Why? Because the reason here is because it is having low resistance. What it is having? It is having low resistance, so it is always connected in series. So the direction of current is taken opposite to the flow of electrons, as electrons were not known the time when the phenomena of electricity was discovered. Okay. Before we were knowing that only the positive charges are flowing in the current and not the electrons. Next we have a potential difference. It is denoted by a symbol V. Work done to move a unit charge from one point to the another. What is a potential difference? It is also called as PD. PD is nothing but work done to move a unit charge. What we are doing here? We are making a unit charge to move from one point to the another point. So let us know what is 1 volt. 1 volt is nothing but when 1 joule of work is done in carrying 1 coulomb of charge, then potential difference is called as 1 volt. Okay. So potential difference, we have a formula. V is equals to W by Q. What is the formula? V is equals to W by Q. So SI unit of the potential difference is volt. What is the SI unit we have for the potential difference? It is volt, and it is denoted by the symbol capital V. So 1 volt is equals to 1 joule per coulomb. What it is? 1 volt is equals to 1 joule per coulomb. Okay. What is 1 volt? When 1 joule of work done in carrying 1 coulomb of charge, then potential difference is called as 1 volt. Okay. So what is 1 volt? 1 volt is nothing but When 1 joule work is done in carrying 1 coulomb charge, then potential difference is called as 1 volt. Okay, this is about the ammeter potential difference. Next we have voltmeter. What is voltmeter? Voltmeter is an instrument to measure potential difference. What we are doing with this instrument? We are measuring the potential difference. Okay, so you may get one mark question. Which is the instrument we are using to measure the potential difference? It is an voltmeter. Or what is the function of the voltmeter? Voltmeter function is the we are measuring the potential difference. Okay, so potential difference. In the previous pages we learnt about that ammeter is only connected for the series, okay, but this voltmeter is it is having high resistivity and always connected in parallel. The symbol you can see on the page, that is V, and you have on the left side plus point and minus point on the right side. Okay, so what is why the voltmeter is used in the parallel, why it is connected in the parallel? The reason here is because it is having high resistivity. What it is having? It is having high resistivity. One more important point to remember about the voltmeter is because the cell is the simplest device to maintain potential difference. Okay, how can we maintain the potential difference? Because by using the cell, as it is a very simplest device. Okay, current always flows from higher potential to the lower potential. Okay, these points you have to remember about the voltmeter. Okay, it is connected in parallel because of its high resistivity or resistance. Okay, symbol is already given. The next, cell is the simplest device to maintain potential difference. The third is current is always flowing from the higher potential to the lower potential. Some of the symbols of some commonly used components in circuits is given, like we have electric cell, battery, key open and key closed, then wire joint, wire crossing without joint, then electric bulb, resistance, rheostat, ammeter and voltmeter. These are the very important circuits. There were definitely 1 mark questions will be asked from these points. Okay, so everyone has to practice these symbols because they are very important to draw even the diagram also, as well as the it will be useful for the MCQs or 1 mark question definitely you will have from these topics. Okay, the next part we have is Ohm's law. What is Ohm's law? We have a definition for the Ohm's law. Potential difference across the 2 points of a metallic conductor is directly proportional to current passing through the circuit, provided the temperature remains constant. It means V is nothing but the potential difference is directly proportional to I is nothing but the current. Okay, so then V is equals to, when we remove that proportionality, we get R is been added. V is equals to R is the constant called resistance of a given metal. What is R? Capital R is a resistance of a given metal. You can see a graph here of the Ohm's law. That is, one side we have the potential difference and next we have an current I. So V is directly proportional to I. Once more I repeat the Ohm's law. Potential difference across the 2 points of a metallic conductor is directly proportional to the current passing through the circuit, provided the temperature remains constant. So the mathematical expression says V is directly proportional to I. As we are removing the proportionality, we are adding up the R. R is nothing but the resistance of a given metal. So you can see the graph and everyone should practice this. Next we have the resistivity. Resistivity is defined as the resistance offered by a cube of a material of side 1 meter when current flows perpendicular to the opposite faces. SI unit is ohm meter. What is the SI unit of the resistivity is? The resistivity is ohm meter. See, we have some more important points of this is resistivity do not change with the change in length or area of cross section, but it changes with the change in the temperature. This point you have to remember here. It means resistivity do not change with the length. If the length is changed or area is changed or area of cross section is changed, it does not changes. It only changes when the temperature is changes. Okay, when temperature is changed, even the resistivity also change. Now we can say that it is directly proportional. So how the temperature increase in temperature, the resistivity also changes. Okay. Next, the range of resistivity of the metals and alloy is 10 to the power of minus 8 to 10 to the power of minus 6 ohm meter. So what is the resistivity of the metals and alloys? Okay. Next, range of resistivity of insulators. You know what are metals, what are alloys and insulators? If you don't know, we'll deeply explain in the lesson metals and non-metals. Okay. Then range of resistivity of insulators is 10 to the power of 12 to 10 to the power of 17 ohm meter. Resistivity of alloy is generally higher than that of its constituent metals. The resistivity of the alloy is generally higher because alloy is a mixture of two or more metals, right? So its resistivity are higher than, so how many metals we are adding in that, based those metals will have the resistivity higher than. Alloys having more resistivity when compared to the metals what we are using. Alloys do not oxidize, that is, they don't burn readily at high temperature. So they are commonly used in electrical heating devices. Okay. So where we are using these alloys, we are using these alloys in electrical heating devices. Okay. Then next we have copper and aluminium are used for electrical transmission lines as they have low resistivity. So what we are using? Copper and aluminium. Why we are using the copper and aluminium? Because they are having low resistivity. Okay. Why we are using the copper and aluminium as an electrical transmission lines? Because they are having low resistivity. Okay. Or you will have a question like which are the two elements which are having the low resistivity, that is copper and aluminium. Okay. Why it is used? It is used because they are having low resistivity in them. Hope you have understood about the resistivity. It is what is it is? It is a resistance offered by a cube of a material that is of one side meter when current flows perpendicular to the opposite phases. SI unit is ohm meter. Okay. So it will not change when the change in the length or area of cross section. It only changes with the change in the temperature. Metals and alloys, what is the resistivity we have? The ranging from 10 to the power of 8 to 10 to the power of minus 6, that is minus 8 to minus 6 ohm. So insulators are from 10 to the power of 12 to 10 to the power of 17. Therefore, the metals and alloys we have minus 8 to minus 6. Okay. Here we have positive 10 to the power of 12 to 10 to the power of 17 ohm. You know that even the alloys is having a higher resistivity when compared to the metals which it is made up of. Okay. And alloys do not oxidize, means they don't burn readily at the high temperature. So they are commonly used in the electrical heating devices. Next, copper and aluminium are used for electrical transmission because they are having low resistivity. This is about the resistivity. So the next we have the resistance in series. What is resistance in series? You can see a picture here. Like we have the resistance are in the form of a series, that is R1, R2 and R3 are in a single line. So you can find an ammeter there and volt is there, key is there, and then I current is flowing. Everything you can see in the diagram. So here when two or more resistors are connected end to end, the arrangement is called the series combination. What is a series combination? When two or more resistors, that is R1, R2 and R3 are connected end to end, the arrangement is called the series combination. So total resistance in series is RS. RS is denoted as resistance in series. So our resistance in series is equals to R1 plus R2 plus R3. So current through each resistor is same. That is current flowing through each resistor, that is R1, R2 and R3 are same. See here, individual resistance is smaller when compared to the equivalent resistance. That is, equivalent resistance is always larger than the largest individual resistance. Okay, this is about resistors in series. Resistance and series is nothing but when two or more resistors are connected to end, the arrangement is called as resistance combination. So total RS is equals to R1 plus R2 plus R3. So the current flowing through each resistors is the same. And then second point is equivalent resistor is larger than the largest individual resistance. The next point is voltage. Total voltage is equals to sum of voltage drops, means V, total voltage is capital V, sum of voltage V1 plus V2 plus V3. Voltage across the resistors, that is V1 is equals to IR1, V2 is equals to IR2, V3 is equals to IR3. So we can take V1, V2, V3 as total as 1 V. Okay, so we can write V is equals to IR. So R1 plus R2 plus R3, I we are taking as common. So it will become V is equals to IR. What it becomes? V is equals to IR. Thanks for watching. We'll meet in the next video. That is a part 2 for the rest of the topics from this chapter. Don't forget to like and subscribe my channel. Thank you.